Let's talk about Java optional. Have you already had the case where you were confronted with null values and had to find a way to handle them gracefully? There's the obvious way of just checking the value for null, meaning if my variable equals null, then something happens. This way provides clarity and conciseness. It is also efficient and very simple to implement. If this is what you need, well then we're already done at this point. So smash that like button and see you in the next video. But if you are curious about another approach, well then stay tuned, because this video is about a Java optional type, which handles null checks gracefully. While direct null checks are often sufficient, optional offers several compelling advantages in more complex scenarios. When it comes to enhanced code readability and intent, optional clearly indicates that a value might be absent, improving code comprehension. By encapsulating null checks within optional methods, you can potentially reduce the number of null checks in your code, making it less cluttered and easier to reason about. Using optional as a return type can make the intent of a method more explicit, indicating that it might return a value or nothing. Let's take a look at some code. We'll start with an easy example of a method to build a full name out of a first name and a last name. I've uploaded the code example of this video onto GitHub, so if you want to check that out, you can find the links to the GitHub repository in the video description below. Alright, so here we have a default Maven structure with build scripts to build the application and run scripts to run the application. Now in the case that you run Windows, you're gonna have to make use of the CMD scripts. And in the case you're running this on Mac or on Linux, you can use the shell scripts. Alright, so let's build up a new class, optional examples. And in here, let's implement a new method, getFullName, taking a first name and a last name as parameters, and returning a string. What we do here is first check whether first name or last name is null. And if it is null, we cannot build our full name, meaning that we return an error, cannot provide the full name. But in the case that both of these parameters are not null, we then can return the string full name, then a blank, and then last name. Alright, that would be it for building the full name using null checks. Now let's take a look at how to do the exact same thing using the optional. Let's again build a new method, getFullName, but in this case we take optional holding a string for the first name and the last name. Then we use the optional method flatMap to access the string value within, and if we do get it, we use the optional map method to get the value within the last name. After that, we call the or-else method for the case that flatMap fails to provide a text, cannot provide full name. And that's about it. So let's take a look at what this looks like when implementing this in the main method. The first thing we need is an instance of the optional examples class, and then we announce what we want to do, null check versus optional. We then define the string variable first name and place John into it. After that, another string variable last name in which we place Smith. And then we do the same thing using optional. To get the value, we use the offNullable method, in which we place first name, which we then save in the first name optional variable. We also do the exact same thing with the last name, and save it in last name optional. As we want to check for nulls, we need the exact same for variables as a null variant. So let's create a new string variable first name null, in which we place null, then last name null, in which we place null, and then we create a string optional first name optional null, in which we use offNullable with a null. And then we do the same thing with last name optional null, in which we also place a null. Now let's create ourselves a first test. Let's try to get a full name using the string variable first name and the string variable last name null. We will put the result in the string variable test1 null check. Now let's do the exact same thing with optional. Here we use first name optional and last name optional null. The result will be saved in test1 optional. And the best way to see the result is to print it to the terminal. So let's do that with test1 full name null check and test1 full name optional, test1 optional. Now let's create a second test in which the first name is null and the last name is set, and save it in a variable test2 null check. Let's also do the same thing with optional, using first name optional null and last name optional, and save the result in test2 optional. Like in our first test, we also print it to the terminal, once the null check and once the optional. And then let's create a third test in which both first name and last name have values, once for the string variant and once for the optional variant. And like the other tests, we print the string variant and the optional variant. And once done, we have an empty line. Alright, so let's take a look at what this looks when running the application. So let's build and run the application. And here we can see the results from test 1, 2 and 3. Test number 1 had a first name, but the last name was null. Both the null check and the optional get the same result. In the second test, the first name was null and the last name had a value. This also leads to the result cannot provide full name in both cases. In the case of the null check as well as in the optional. In test 3, both the first name and the last name have values. This time we will get a result. And this is John Smith for the null check and for the optional. When using optional, there are several ways to access the data within the optional. 2 of them are the map and the flat map methods. With both we can do the same thing in our case, but their approach is a bit different. Let's take a look at how to make use of them. Alright, we're back in the optional examples.java. Let's create a new method, getValuesWithMap. For this test case, let's also create a new class, animal, which has a string variable called name, for which we define ourselves a set method, setName, which has a string parameter name, and saves it within our private variable name. We also need a get method, getName, which returns the private variable name to the caller. Alright, we're ready to use it. Let's go back to the optionals example.java. Let's create a new instance of the animal class and save it within an animal variable. We can set the animal name to Nala and then place the animal into an animal optional, for which we make use of the method of nullable. To get the value within the animal optional, we create ourselves a new string optional, name optional with map, and then we get the value using the animal optional variable, .map, and so that map knows what we want, we provide the class name and the method name, which in our case is getName. Now let's check if the value is within our variable name optional with map. For that we use the isPresent method. If this returns true, it means that the value is within it. In this case we can return it to the caller using get, but if it is not present, we return name is null. Now let's take a look at how to do the exact same thing using flatMap. For this we implement a new method, getValuesWithFlatMap, in which we again create a new instance of the animal class. Then we set the name Nala, and then we place the animal in the optional using ofNullable. And to get the value, we create ourselves a new string optional, name optional with flatMap, and then we access animal optional using flatMap. Then we define ourselves a variable name flatAnimal and use optional ofNullable to access the name of flatAnimal. And now that we've done that, we can again check if the value is present, and if it is, we use get to return it to the caller, and if not, we return name is null. Now let's go back to the main method and create ourselves a test. The first thing is that we announce what we are doing, get values using map and flatMap, and then we create a string variable, getName with map, in which we access optional examples and get the result of getValuesWithMap. And then we create ourselves a second string variable, getName with flatMap, in which we put the result of getValuesWithFlatMap. Now let's print the results to the terminal for map and for flatMap. Alright, we can now build and run the application. And here we can see get values using map and flatMap. And the first test case, get animal with map, results in Nala. And get animal name with flatMap also results in Nala. In order to react differently on existing and non-existing values, optional offers the if, present or else method. This is a method that takes 2 consumers as arguments. If the optional instance contains a value, the first consumer is executed with a value. Otherwise, the second consumer is executed. This method provides a concise way to handle both present and absent values in an optional instance. Let's take a quick look at some code and see how to make use of that. Okay, we are back to the optional examples.java. Let's implement a new method, getValues if, present or else, taking a string name. As the name could be null or not, we use optional ofNullable to take the name and place it in the optional string maybe name. Now we can make use of the if, present or else method, in which we define the name and then execute the systemoutPrintln method to print name equals and then the name. But if it is not present, we execute systemoutPrintln name is null. Now let's go back to the main method and implement the test. Let's print the text to the terminal, get animal name with if, present or else, in which we provide Nala. Here we access optional examples.getValues with if, present or else, in which we provide the string Nala, and then we print another text get animal name with if present or else, in which we provide null. Here again we use optional examples, get values with if present or else, and we provide null. Now let's build and run the application. And here we can see the first line, get animal name with if present or else nala, which equals to name equals nala. And then we have the second test, get animal with if present or else, in which we provide null, which results in name is null. Optional also provides different ways of getting values in and get set up. One way is the off method, providing a simple way to wrap a value in an optional context. While this works with present words, it cannot handle absent words, meaning that taking null as a value is not possible with the off method. For this, there's the off nullable method, which does essentially the same thing as the off method, but includes the possibility to handle null values. There's also the empty method to define an empty optional. Let's take a look at a couple of examples. Alright, we're back in the optional examples.java. Let's implement a new method taking values, which returns void, which means nothing. The first test is using off and provide a string, which we want to put in the optional string value a1. This works without any problems. The next thing we want to do is provide a null value in the off method. This will end up in an error because off does not take null. So in this case we have to comment it. The next test is providing a string to off nullable. This works perfectly fine and we can save that in the optional string a3. The fourth test is providing a null to the off nullable method. This also works perfectly fine and we can save the result in the optional string a4. The fifth and last test that we do is creating an empty optional. For this we simply call the empty method and place the result in an optional string a5. Now let's print a1, and as we have no a2 variable, comment it, then we print a3, a4 and a5. Now let's go to the main method and announce what we are doing, taking values. Now we execute the taking values method and print a new line. Alright, let's build and run the application. And here we can see the result. In a1 we get the optional with the value maxi, having the string variable maxi. a2 does not exist. Then a3 also an optional with maxi. And a4 was the test with off nullable providing a null, which results in empty. And a5 was created by using the optional.empty method. Optional also supports method chaining, allowing for elegant and concise expressions of complex operations. What this means is that we have our standard optional variable, which may have a value that we want to access. We might only want this value on certain conditions though. One of these conditions might be to upper or to lower all the letters of a string. Another condition might be that we only want the given text value if it has a certain minimum length. Within the same chain, we can also define a default value for the case that one of the other conditions fails. Let's take a look at how to implement this. Okay, we're back in the optional examples.java. Let's implement a new method, getNameConditional, taking a string name and returning a string. In here, we start by creating a new optional string variable, maybe name, in which we place optional off nullable and provide the name. Now we build our result and save it in the string variable result. Here we access the variable maybe name using map to uppercase the containing string value, and then we use filter to only take results where the string has a length of greater than 5. If this fails, we define ourselves an or-else method in which we provide the string default name. Last but not least, let's return the result. Now let's go to the main method to implement the test. Let's first announce what we are doing, method chaining, and then let's create a string variable name1 in which we put the result of getNameConditional in which we provide John. Let's create a second test in which we provide David, another test in which we provide Michael, and another test in which we provide Christopher. Now let's print name1, name2, name3, and name4. Alright, we are ready to build and run the application. And here we can see the results of method chaining. The tests for name1 and 2 failed the condition of having a name length greater than 5, and therefore we get default name. The tests for name 3 and 4 had names greater than 5 letters and also had all the letters put to uppercase letters. For cases when the values are absent, optional offers the methods or-else and or-else get. We already covered in a conditional chain example what the or-else method does. The or-else get method can do the same thing, but has a slightly different approach of doing so. Let's take a look at two examples. We are back in the optional examples.java file. Here let's implement a new method, provide default value with or else, which takes a string parameter, email, and the method returns a string. In here we define a new optional string, maybe default, and then we make use of optional of nullable, in which we place email. Now we can return the value maybe default, and if it fails, we use or else, in which we provide default at example.com. Let's also implement another method, provide default value with or else get, which also takes a string parameter email, and the method returns string. Here we start by creating a new optional string maybe default, and then we make use of optional dot of nullable, in which we provide email. Now we first return maybe default, and then for the case that this failed, we use or else get and provide an anonymous method in which we first announce a text given email was null, generating default email. And then we return default at example.com. Alright, let's go to the main method and implement the tests. Let's first announce what we are doing. We provide defaults. Now let's create a string variable mail1 in which we use provide default value with or else, providing the email test at example.com. Then we print whatever is in mail1. And then we create a second test accessing the same method, provide default value with or else, but this time we provide null, and save it in a string variable mail2, followed by printing mail2 to the terminal. Now let's create another string variable mail3, in which we access provide default value with or else get, in which we provide test at example.com, then we print it to the terminal, and then we create a fourth string variable, mail4, in which we access the provide default value with or else get, in which we provide null. And then we print it to the terminal. Now let's build and run the application. And here we can see mail1 resulted in test at example.com. Mail2 did not work. Mail2 was only provided null and therefore resulted in default at example.com. Mail3 resulted in test at example.com, which we provided to the method. And mail4 resulted in a default at example.com because the given email was null, so we had to generate a default email. Optional helps prevent null pointer exceptions by providing methods like or else get, and if present, to handle absent values gracefully. As we have seen, you can easily provide default values or perform alternative actions when a value is absent. In the case that this is not enough, you might want to look into creating your own custom exception. While explaining the entire functionality of exceptions might go beyond the scope of this video, I still want to take the opportunity to show you the or else throw method, which allows to handle a case by defining a custom exception. Let's take a look at how to implement that. We are back in the optional examples.java file. Here let's implement a new method, throw default exception, taking a string parameter email and returning a string. This method also throws an exception called myCustomException. Before we implement that, let's first implement an optional string, maybe default, and then we make use of optional dot of nullable, in which we place email. Then we return maybe default, and then we make use of or else throw, in which we provide a new instance of our custom exception and provide a text myCustomMessage. Now let's create a new class, myCustomException, which extends exception. While this is not strictly necessary, we will still create a new constructor, in which we make a call to the superclass constructor of exception. We will also create a second constructor, which takes a string parameter for the message. In here we also provide a superclass with a message. And that's all we need. Let's go to the main method. Let's first announce what we are doing. Let's call it error handling. Here we first build up a try-catch context, in which the catch part handles the myCustomException. In the try part we define a new string variable, throw1, in which we place the result of throw default exception, for which we provide test at example.com. After that, in the case of success, we print throw1 error and the appropriate message. Let's repeat this entire test, but this time we provide null and the rest remains the same. Now let's build and run the application. And here we can see throw1 results in test at example.com and throw2 results in an error in which we see myCustomMessage. To sum up, we first made sure we understood the basics of optional and what its advantages over the traditional null check. We then went on to create a collection of code examples, starting with the basic null check and optional. We then continued with showing the map and the flat map methods, followed by showing how to take values using the methods of nullable, and empty. After that, we took a look at a way of handling absent values using the if present or else method, also showing a more complex example using conditional chains, and further examples using the or else and or else get methods. Last but not least, we took a look at how to throw custom exceptions for absent values. Did you like the format and the content of this video? Drop a like and subscribe to this channel. This is a good way to get notified about future videos with contents like this one. My name is Gene. I would like to thank you very much for watching and see you in the next video.